Hello everyone. Sorry for this late video. I was pretty excited about OnePlus 6 India launch. So let's get started. In this video, we are going to look at discrete Fourier transform, also known as DFT. Okay. Now the numericals from this chapter are pretty much nearly the same. Okay. The logic applied is same. You will be given either x of n or x of k. If you are given x of n, then you will be asked to compute x of k. Okay, that is find the DFT of x of n, which is x of k, or you will be given x of k and then you will be asked to find x of n. Okay, so let's get started. Let's look at the first question. We are given the first 5 points of 8-point DFT of a real valued sequence are this 0.25, 0.125 minus j 0.3018, 0, 0.125 minus j 0.0518, and lastly 0. Now there are 5 points given. Okay, if I counted 1, 2, 3, 4 and 5 points are given. So, and it is told that it is 8-point DFT, so we have to calculate the remaining 3 points. Now, if you are something into computer science, you will understand that as arrays are named from 0th position, here also it will be named from 0th position. So 0.25 won't be the first place, it will be 0th place. So this is my x0, x1, x2, x3 and x4. And remaining we have to calculate x5, x6 and x7. So let's get started. So since this is a 8-point DFT, my n is equal to 8. Now I will write down all the values that I am being given, x0, x1, x2, x3, x4, which is nothing but given in the question. Now since it is told that x of n is real valued, so by symmetry property of DFT, x of k is equal to x star of n minus k. Look at this property very carefully, okay? Like remember this property because in all our questions we are going to use it at some point or the other. So here my n is nothing but 8, which is total number of terms. My k is not known and actually I have to calculate x of k. So let's calculate x of 5. So in place of k I will have 5. So I will have x star of 8 minus 5. 8 minus 5 is nothing but 3, which means x star of 3, and x star of 3 is already given in the question, which is 0.125 minus j 0.518. So that is the answer for x of 5. Similarly, x of 6 is nothing but x star of 8 minus 6, which is x star of 2, which is nothing but 0. And x of 7 is 8 minus 7, which is x star of 1, which is nothing but 0.125 minus j 0.3018. So with this, we get all the terms of the 8-point DFT. 5 were given and remaining 3 were calculated. Pretty simple, isn't it? Now let's move on to the second question. We are given that x of n is equal to 1 when n is between 0 and 3, both included, and 0 when n is between 4 and 7, both included. We have to find first x of k, which is in the question it will be asked find DFT x of k. Okay. So first we need to write down x of n. In the previous question you saw it was nicely written. Okay. So in the same way we'll write it down. Now x of n for 0th position it is 1. So I have written 1. For first, second and third all it is 1. So I have written 1, 1, 1. From 4th position to 7th position it is 0. So 4, 5, 6 and 7 it is 0. So that is my x of n. Now let's write capital N. My capital N will be nothing but 8. Okay. Now, one thing to remember, x of, I can say like n, okay, is nothing but omega capital N raised to nk, and I can further expand, sorry, this is x of k, and I can further expand it to e raised to minus j 2 pi nk by n. Now what are these terms that I'm talking about? This, okay, can be like further expanded into matrix form. Remember this formula. We're not going to use it in the first part, but you can always solve using this. What you have to do is, this capital N is nothing but my total number of points, which is 8. Okay, k will vary because k, like we have to calculate x0, x1, x2, x3, so k will vary. Small n, even that will vary depending on the question. By substituting the values, you will get x of k. But instead of that, I have a better option of matrices. Now, as I told you, this is nothing but omega n raised to nk, okay, or wn raised to nk. Look at these two terms, n and k. My k, as I told you, it will go from 0 to 7, and my n will also go from 0 to 7. Let's not get into the details, but what I need to do here is first write n 0 to 7, then write k 0 to 7, and then multiply each term. So 0 into 0 is 0, 0 into 1 is 0, 0 into 2 is 0, 0 into 3 is 0, 0 into 4 is 0, 0 into 5 is 0, 0 into 6, 0 into 7. Like multiply any of the two terms and write the product here. So you will have 2 into 1, 2, 2 into 2, 4, 2 into 3, 6, 2 into 7, 14. Okay. You will have 5 into 1 is 5, 5 into 2, 5 into 3, 5 into 4, 5 into 5, 5 into 6, 5 into 7. Similarly, lastly we will have 7 into 0, which is 0, 7 into 1, 7 into 2, 7 into 3, 7 into 4, 7 into 5, 7 into 6, and 7 into 7. Now, just go back a little. Here I wrote omega n raised to nk. What is this? As you saw previously, I had 8 terms. So this is nothing but omega 8. And this nk, which means product. So if I have 0, n as 0, k as 0. So what I am getting is 0 in the matrix. Okay. If I have n as, like, let's say k as 1, n as 1. So I will have omega 8 raised to 1. If I have k as 7 and n as 7, I will have omega 8 raised to 49, right? Because 7 into 7 will give me 49. We have to calculate these values, and you all know the formula, that is e raised to minus j 2 pi nk by n. Nk we already found out from this graph. Okay, nk we found out from this graph, and what you will need to do is e raised to minus jn. Let's say we are calculating for 49, minus j 2 pi, okay, into 49. Okay, let me write it down. E raised to minus j 2 pi into 49 divided by 8. Just cancel out whatever is getting cancelled, and then you have to expand it. Cos of whatever the term is you are getting minus j into sine of whatever you are getting. And by whatever you are getting, I mean, let's say if I write this 2 pi into 49 by 8 minus j sine 2 pi into 49 by 8. So like this you have to do for every term. You have to write like, if you are having omega 8 raised to, let's say n, let's say k is 3, okay, and n is 4, so we'll have omega 8 raised to 12. So that will be expanded as e raised to minus j 2 pi into 12 by 8. So this will be further expanded as cos of 2 pi into 12 by 8 minus j sine 2 pi into 12 by 8. What you have to do? Basically put these terms in the calculator and you will get your answer. Now the hectic part is you have to calculate it for 49 terms. Can you even imagine that? 49 terms. It's way too much. So what I have here for you is something like this. I can write here, okay, and this is something which will be very useful. Omega 8 raised to 0, omega 8 raised to 1, omega 8 square, omega 8 cube, omega 8 raised to 4, omega 8 raised to 5, omega 8 raised to 6, omega 8 raised to 7. Okay. Now omega, add, like you have n equals to 8, right? Your n is 8, which is the number of terms. I am talking about the capital N. Capital N is equal to 8, which is number of terms. What you need to do is just add 8 to the preceding value. Previously you had 0, add 8 to it, you will have omega 8 raised to 8. Then omega 8 raised to 8 plus 8 is 16. You will have omega 8 raised to then 24, omega 8 raised to 32, omega 8 raised to 40, and then you will have omega 8 raised to 48. But 48 is nowhere in this table, okay? So just discard it. And what you need to do, just calculate the value of omega 8 raised to 0. Whatever be the value of omega 8 raised to 0, the same value will be for all of these terms. Okay, beautiful, isn't it? And actually that will come out to be 1. Similarly, omega 8 raised to 1, add 8 to preceding value. You will have omega 8 raised to 9, omega 8 raised to 17, omega 8 raised to 25, omega 8 raised to 33, omega 8 raised to 41, omega 8 raised to 49, and nothing further. And that value will come out to be actually 0.707 minus j 0.707. So you have to just calculate for omega 8 raised to 1, and for all of these terms the value will be the same. Similar logic applies to omega 8 square. Next term will be omega 8 raised to 10. Just calculate for omega 8 raised to 2. Okay, and the answer will be the same for omega 8 raised to 10, omega 8 raised to 18, 26, 34, 42, so on. Okay. Similar for cube, 4 raised to 4, 4 raised to 5, 4 raised to 6, 4 raised to 7. Let me write the values. If you want, you can remember it, but I guess that remembering the logic would be a much better option. So this will come out to be minus j, this will come out to be minus 707, minus j 0.707, this will come out to be minus 1, this will be minus 0.707 plus j 0.707, this will be equal to j, and this will be 0.707 plus j 0.707. So with this you have calculated the matrix. What you need to do, just write down all the values. Okay, I have written just 1, 2, 3, 4 and 5 columns. You have to write the remaining 3 columns more, okay, which I have represented by dotted lines. Write all the columns and then you have to multiply it by x of n. The answer, like multiplication, is, as you all know, row multiplied by column. Okay, multiply it. Only you have to actually multiply the 4 columns, because after that the 4 rows are 0, 0, 0. Okay, and then add it together, you will get the final answer of x of k. So yeah, it looks a bit lengthy, but it is not as lengthy as we think. And with practice, which I guess only hours are remaining for practice for this chapter, you can just remember the trick to find omega and then you can solve this question. Now in this same question, okay, it is given that x1 of n is equal to 1 for n equal to 0, and it is 0 for 1 to 4 both included, and 1 for 5 to 7 both included. So let's write it down. For n equal to 0 I have 1, for 1, 2, 3 and 4 I have 0, for 5, 6 and 7 I have 1. Okay, and what is asked? You have to find the DFT of this. Okay, but by using the results you obtained previously. No new results are to be used. You have to use the results that you obtained previously and then find the sequence, then find the answer. Suppose it was not told this, you could have easily like written down the matrix, multiplied it by x1 of n, and you must have got the answer. But since it is mentioned that you have to use this x of k which you previously got, let me tell you one thing. You are given this x1 of n as 1 0 0 0 0 1 1 1, and my x of n was 1 1 1 1 0 0 0 0, right? What I can do, let's move things in anti-clockwise direction. Anti-clockwise means this direction, right? If you can see my movement, anti-clockwise is this direction. So let's move this 0 further, like in forward. So I'll have 0 and then 1 1 1 1 0 0 0. Again 0 0 1 1 1 1 0 0. Again 0 0 0 1 1 1 1 and 0. Again 0 0 0 0 1 1 1 1. Okay, and then one more time 1 0 0 0 4 times 1 1 1. Now this sequence that you got, this was my x of n, remember, and this is my x1 of n, right? Because it looks similar, very much similar. How many times did we move it? 1 2 3 4 and 5, right? So I have a property called as circular time shift property, which is something like this. If you have x of n minus L for n, I can write, like I can find x of k for the new sequence as x of k of the previous sequence multiplied by e raised to minus j2 pi lk by capital N. Looks very much similar to the previous formula that we saw. In place of nk, I just have lk. Everything else remains the same. So what is this L? This is the number of times that you shifted. I shifted it 5 times, right? And this capital N remains 8. It is equal to previous of xk into e raised to minus j2 pi. In place of L, I will have 5k, by in place of N, I will have 8. Now if I have to find the new x1 of k, that will be nothing but x of k old one multiplied by e raised to minus j2 pi. Sorry, I forgot the 2. It's 2 pi 5k by 8. Now if I have to find x1 of 0, that is nothing but x of 0 multiplied by e raised to minus j2 pi 5 into 0 by 8. X of 0 previously was, sorry, not this, this. Here x of 0 was 1, right? X of 0, that means x, I'm talking about x of n. Sorry, I'm really sorry. X of 0, that is in x of k, which we got here. X of 0 is this. This is x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. I'm talking about this x of k. Okay. So this is nothing but 4 multiplied by e raised to minus, it will become, the whole thing will become 0 actually, by 8, which is nothing but 4 into e raised to 0, which is nothing but 4 into 1, which is nothing but 4. So the first term that you will get will be 4. Similarly, if I am asked you to find x of x1 of 1, that is nothing but x of 1 multiplied by e raised to minus j2 pi 5 into 1 by 8. Now x of 1 is 1 minus 2.4142j, right? Multiplied by this term. 1 minus, it was 2.4142j multiplied by e raised to minus j 2 pi 5 by 8. I can expand it using cos of 2 pi 5 by 8 into, sorry, minus j sine 2 pi 5 by 8. Put this in calculator, whatever answer that you get, multiplied with this number and you will have x1 of 1. Similarly, you can find x1 of 2, x1 of 3, x1 of 4, x1 of 5, 6, 7, and that will give you your answer. Okay. And now trust me, this is the simplest method you will ever get, and the best reason for telling this to you is because This answer is not documented anywhere, neither in Easy Solution nor in TechMax nor anywhere else. So you can use this method and find the answers. Okay. This was a question of I guess May 15. Okay. And in this same, you were also given x2 of n, and that was equal to 0 when 0 was less than equal to n less than equal to 1. It was 1 when 2 was less than equal to n less than equal to 5, and it was given 1, but actually it must be 0. Okay, in the question paper it was given wrong. It was given 1 here, but it should be 0. 6 less than equal to n less than equal to 7. You can use the same formula. First find x2 of n. Okay, write x2 of n. After writing x2 of n, what you need to do is compare it with x of n. I had 1 1 1 1 0 0 0 0. Move in anti-clockwise direction. If I move once, I will have 0 1 1 1 0 0 0. Move another time, 0 0 1 1 1 1 0 0. This is nothing but x2 of n, right? How many times did we move? 1 2. Okay, we moved it just 2 times. After x of n, we moved it 2 times. So I will have, instead of x of n minus 5, as we saw previously, I will have x of n minus 2, and everything changes accordingly, and you will get your final answer. Now with this we end this question. Let's move on to the next question. Very much similar, very much similar actually. I am given that x of n is 1 2 3 4, and I am told to find DFT of x of n, which is basically x of k, and using the results obtained I have to calculate values for all these. First thing, write x of n. Okay, after writing x of n, calculate the matrix. Now this will be a 4 cross 4 matrix, right? So you will have 0 1 2 3 0 1 2 3 0 into 0 0 into 1 0 0 0 0 0 0 1 into 1 1 2 and 3 2 into 1 2 4 and 6, and here I will have 3 1s are 3 3 2s are 6 and 3 3s are 9. Okay, then discard all of this. Here I will have omega 4 raised to nk will be like 0, omega 4 raised to 1, omega 4 raised to 2, omega 4 raised to 3. The values will be add 4 to previous one, omega 4 raised to 4, add 4 to it, omega 4 raised to 5, and omega 4 raised to 9. Also here if you add omega 4 raised to 6 and omega 4 raised to 10, which is not existing in this, and here you will have omega 4 raised to 7 and omega 4 raised to 11. Just calculate the values of these terms. It will be same for other terms. Put these values, multiply the answer obtained, the matrix obtained by x of n, 1 2 3 4, and then you will have your final answer, which is x of k. By solving this, multiply the row by column, you will have x of k. Okay, now the second part. A of n is given 4 1 2 3. Just compare it with the question. 1 2 3 4 4 1 2 3. Just move 4 forward, okay, in anti-clockwise direction once. You will have 4 1 2 3, which means, as we saw in the previous one, x of n minus l. In place of l, now I will have 1. Put those values, you will get the answer. Okay, similarly 2 3 4 and 1. First move 4 once, then 3, then again, or even better, what you can do is just move this 1 ahead. Okay, if you move 1 ahead, instead of x of n minus l, you will have x of n plus l. Now this l will be equal to 1. Now please understand this and look at this very carefully. Previously I had not, let me see. Okay, previously I had this thing, e raised to minus j 2 pi lk by n, and l was written directly whatever we were seeing, right? We had l equal to 5, so I wrote just 5 here, and look at this sign, it was negative sign. Now we have positive sign. So what happens to this L? Does it remain plus 1 or does it remain, will it change? My standard formula says that it should be in the form of x of n minus L. But here I have plus. So what I will do, instead of n plus 1, I will write it as n minus of minus 1. Okay. So my L is now minus 1. So here I will have e raised to minus j2 pi. Instead of L, I will have minus 1k by n. Okay. I hope you understand. Standard formula says there should be negative sign here, but we have positive. So we can write it as negative of negative. Then change accordingly, multiplied by x of k, which you have got here, x1 of 0, x1 of x, sorry, then you will get the sequence for B. Similarly, if you look at C, 3 4 1 2, 3 4 1 2, move 4 ones, then move 3 ones, like you are moving in anti-clockwise direction twice, anti-clockwise direction. Okay, move 4 ones, then move 3. You will have 3 4 1 2, and you are moving in anti-clockwise direction twice. So your L will be equal to 2. Here L was equal to minus 1. Here L was equal to plus 1. And this final 4 6 4 6. Can you even find 6 here? We can't. So what to do? That is the question. Look at this C of n. This is 3 4 1 2 and this is 1 2 3 4. If I add the first term and first term, 1 plus 3 will give me 4. 2 plus 4 will give me 6. And today was the launch of 1 plus 6. Then 3 plus 1, it will give me 4. And finally, I will have 4 plus 2, which will give me 6 again, which is very much or actually same as D of n. So what property do I use here? I have this property, very interesting property called as linearity property. Okay, I can write x of k, like x d of k, equal to x of k for n, x n of k plus x c of k. Now what do I mean by that? I have to find x of k for this d of n, right? I have to find x of k for that. I have already found the x of k for this given question, x of n, and I have already found this x of k for this given c of n. I told you how to find it. What you can do, just add, and since we see that d of n is nothing but x of n plus c of n, so d of k must also be equal to c of k plus x of k. So just add the values that you get and finally you will have xd of k, which was asked in the question. Simple, isn't it? Most of the books have documented it like with a different and very weird kind of formula. But if you use this linearity property, you can easily get the answer, and by answer I mean the correct answer. Okay. And moving on to the last question. Now this is the last question for this video. I am given that x of n is equal to 1, 2, 3, 2 and h of n is equal to 5, 6, 7, 8. I have to find circular convolution using time domain method. Okay. Circular convolution using time domain method. Does this name ring any bells? Well, to me, circular convolution using time domain means circle is involved, which means rotation will be there. So yes, there will be something like shifting in anti-clockwise direction. Now first thing to remember, first you will write x of n here, okay, then you will multiply it by h of n, and whatever answer that you get, that will be your final y of n. Okay, now let's decide the matrix size. H of n I know is 5, 6, 7, 8. Now as you all know, for matrix multiplication, the number of columns for this should be equal to the number of rows for this. Okay, here I have 4 rows, and if I write just x of n, I will just have 1 column. So what I will do is, first I will write 1, 2, 3, 2, x of n, first column, which is as given in the question. Then I will shift this last 2 to first, and remaining will get pushed downwards automatically. Then push this 3 up. You'll have 3, 2, 1, 2, and then push this 2 up. You'll have 2, 3, 2, 1. Now I have 4 columns, 4 rows, multiply it. And multiplication is row multiplied by column. Okay. Multiply it. 1 5s are 5, plus 2 6 are 12, plus 3 7s are 21, plus 2 8s are 16. The answer will be equal to 54. Similarly, you will have 54, 54, 50 and 50. Multiply it and check it. Now this is your circular convolution. Step 1 is over. Part 1 of the question is over, where you were asked to calculate circular convolution using time domain method. Simple. First write x of n multiplied by h of n. The number of columns in h of n decides how many times you have to go on doing this thing of pushing it up and down. Multiply it and then you'll have your answer. Second part of the question is to find circular convolution using DFT or IDFT method. Okay, DFT or IDFT method. So here I'll have x of n and I have to find x of k, right? Using DFT IDFT, which is nothing but actually butterfly method. Okay, so what happens in butterfly method? You will have, since you are having 4 terms here, in butterfly method, first for 4 terms, which means you will draw 4 lines. 1, 2, 3, 4. Okay. Now here this is DIT method, which means it goes from small to big. By what is small and what is big? We'll see. Here I'll write x0, x2, x1 and x3, and finally answer will be x of 0, x1, x2 and x3. This is standard. Okay, there is no questioning this. This is standard. If you are given 4 terms, you'll have 0, 2, 1, 3. If you are given 8 terms, okay, if you are given 8 terms, please listen to this carefully. If you are given 8 terms, you'll have 0, 4, 2, 6, like x0, x4, x2, x6, and then 1, 5, 3, 7. And the order remains the same, 0, 4, 2, 6, 1, 5, 3, 7. No changing in the order, otherwise you will get wrong answer. If you had 8 terms, but here you just have 4 terms, so just leave this. Coming back, I have 0, 2, 1, 3. What you have to do is make a cross. The first, the second, the third line remain 1, 1, 1 and the base is minus 1. Then leave 1 and then again make a cross. 1, 1, 1, minus 1. Then draw a dotted line here. Now you had used 1 box, right, for making the crosses. Now you will use 2 boxes. So you will have a cross like this, 1, 1, 1 and base is minus 1. Then you'll have a cross like this, 1, 1, 1 and base is minus 1. Okay, I hope you understood till here. What is the next step? Well, the next step is you have to write here omega 4 raised to 1 and here omega 4 raised to 0. Standard, no questioning it. Omega 4 raised to 1, omega 4 raised to 0. Now what you have to do, okay, you have to write the values of x of 0. X of 0 was nothing but 1, okay, which I am writing from x of n, which was given in the question. X of 2 was 3, x of 1 was 2 and x of 3 was 2. So 1, now here is 1 and here is 3, here is 2 and here is again 2. 1 into 1 plus 3 into 1 will give me 1 plus 3, which is nothing but 4. 1 into 1 plus 3 into minus 1, which is 1 minus 3, which will give me minus 2. Here 2 into 1 plus 2 into 1, which is 2 plus 2, which is nothing but 4. And here 2 into 1 minus 2 into like plus 2 into minus 1, which is 2 minus 2, which is nothing but 0. Now this carries forward to here 4, this carries forward here 2, this 4 into omega 4 raised to 0. How to calculate omega 4 raised to 0? I know that omega capital N raised to nk is equal to e raised to minus j 2 pi nk by n. Capital N is 4, nk is nothing but 0. So here it becomes e raised to minus j 2 pi, in place of nk you will have 0 multiplied divided by 4. This will come out to be 1. So here you will have 1. So 4 into 1, that will give you 4. So here you will, at the base you will have 4, and this is 0. 0 multiplied by omega 4 raised to 1. Actually omega 4 raised to 1 will come out to be minus j, but 0 multiplied by it will give you 0. Okay. Now next step, again 4 into 1 plus 4 into 1, 4 plus 4 will give you 8. Next 4 into 1 minus 4 into 1 will give you 0. Okay, and then similarly you will have this 2 into 1 plus 0 into 1, which will give me 2 plus 0, which is nothing but 2. Okay, sorry, this was minus 2. So minus 2 into 1 plus j into 0 will give you minus 2, and here I'll have minus 2 into 1 plus 0 into minus 1, which is nothing but again minus 2. So 8 minus 2, 0 minus 2. This is the answer for x of n using circular convolution. Okay, using DFT and IDFT method. Like this is my x of k using DFT and IDFT method. Similarly we have to find h of k. H of k. To find h of k, make 4 lines, butterfly, like box, and then dividing line, then box, and then box again. Write the values, multiply it, omega 4 raised to 1, omega 4 raised to 0, please don't forget them, and then you will get your final answer. The final answer will be something like this for h of k. Okay, for h of k, the final answer is 26 comma minus plus 2j, minus 2 plus 2j, comma minus 2 comma minus 2 minus 2j. Okay, now we have to find y of k. Y of k is nothing but x of k multiplied by h of k. Okay, so 0 0, x of 0 into h of 0 will be y of 0, which will come out to be 208. Y of 1 will be x of 1 into h of 1, which will come out to be 4 minus 4j. Y of 2 will be x of 2 into h of 2, which will come out to be 0, and y of 3 will be h of 3 into x of 3 into h of 3, which will come out to be 4 plus 4j. Now this was your y of k, and what to do further? You have y of k and you have to find y of n. Y of n is basically what you had got previously. Previously you had found y of n using circular convolution method, circular convolution using time domain method. Now you have to find y of n using this DFT and IDFT method, which is discrete Fourier transform and inverse discrete Fourier transform. Okay, so now we have to find inverse of this. First make 4 lines, and then inverse. This is inverse, right? And if it is inverse, so whatever we were doing previously, we were making small crosses and then big crosses, even that should get inversed, right? Or what you can do is write y of 0, y of 1, y of 2, y of 3 here, and here you write y of 0, y of 2, y of 1, y of 3. Just make small crosses here, then leave one and then make big crosses here. Okay, here it will come out to be omega 4 raised to 1, here it will be omega 4 raised to 0. Nothing changes here. Write the values that you got here, which is 208, 4 minus 4j, 0 and 4 plus 4j. Like here you'll have 1, 1, 1, base is minus 1, 1, 1, 1, base is minus 1. Do what we did before. Find the values of these points. Multiply the answer you got here with this. Then multiply it again. And here you will get the answer, which will be 216 and like 216, 200, 200 and 216, something like of that sort. Okay, what you have to do is divide that answer by 1 by n, like actually not divide, multiply it by 1 by n, whatever you got here, whatever you get here, multiply it by 1 by n. So here n is 4, so 1 by 4 multiplied by the first term, you will get 54, then 54, then 50, then 50. You will have 4 terms here, multiply each of them by 4 and you will have 4 answers, and this answer should tally with the answer that you got previously. Then and only then it will be assumed correct. Okay, and to come to the final part of this question, we are told to find linear convolution using circular convolution. I know this video is getting a bit big, but this video will cover all aspects of chapter 2, which is discrete Fourier transform. Okay, now linear convolution using circular convolution. This is the final part of this question that we are doing. We have to first calculate the length of my linear convolution. So my length is equal to m plus n minus 1. M is the number of terms in x of n is the number of terms in h of n, and subtract 1 from them. So I will have here 4 plus 4 minus 1, which is nothing but 7. 4 plus 4 is 8, 8 minus 1 is 7. So which means length must be equal to 7. But my x of n, as you remember, was only 4 terms. It was 1, 2, 3, 2. So what about the remaining 3 terms? If they are not there, just write 0, 0, 0. Similarly for h of n was 5, 6, 7, 8, just 4 terms. What about the remaining 3 terms? 0, 0, 0. Now, as you all saw previously, we have already done this circular convolution. First write x of n. Okay, now x of n will have 1, 2, 3, 4, 5, 6, 7 multiplied by h of n, which will be 5, 6, 7, 8, 0, 0, 0, and whatever answer that you get will be your final answer, which will be nothing but y of n. Here there are 7 rows, that means there needs to be 7 columns. So first we'll write 1, 2, 3, 2, 0, 0, 0, whatever was the question. Okay, now move this 0, 1 like forward. You'll have 0, 1, 2, 3, 2, 0, 0, then again 0, 0, 1, 2, 3, 2, 0, then again you'll have 0, 0, 0, 1, 2, 3, 2. How many columns are done? 1, 2, 3, 4 columns are done. 3 more columns to go. Then you'll have 2, 0, 0, 0, 1, 2, 3, then again 3, 2, 0, 0, 0, 1, 2, and then again 2, 3, 2, 0, 0, 0, 1. Now 7 columns are done. 1, 2, 3, 4, 5, 6 and 7 columns. 7 columns multiplied by 7 rows will give me y of n, which will be 7 rows long. Now since in this question it was told to find linear convolution using circular convolution, okay, that is why I had to do all this blunder. Okay, 5, 16, 34, 50, 49, 38 and 16. This will be your final answer. Suppose in the question it was just told to find linear convolution and method was not specified. What you could do is just write 1 like x of n, right? X of n, which was 1, 2, 3, 2. Then write h of n here, which is nothing but 5, 6, 7, 8. And what you need to do is multiply them. 5 into 1 is 5, 5 into 2, 10, 5 into 3, 15, 5 2s are 10, 6, 12, 18, 12, 7, 14, 21, 14, 8, 16, 24, 16. And then forget about these x of n, h of n. Just write the addition. Here it will be just 5. Here it will be 10 plus 6, which is 16. Okay, this is just 5. This will come out to be 16. This will be 7 plus 12 plus 15. Okay, this will come out to be 34. Then you'll have 8 plus 14 plus 18 plus 10. This will come out to be 50. Then 16 plus 21 plus 12. This will come out to be 49. Then 24 plus 14. This will be 38. And then just 16. Compare this answer with the answer that you got. They are both are the same. So if you are just told to find linear convolution, better use this method. Or if you are told to find linear convolution using circular convolution, first find the length, then add the number of terms. Okay, you will never have to subtract, you will just have to add zeros at the end, then the number of columns multiplied by number of rows, you will get the final answer. With this, we end this chapter. I'm sure that nothing else is being asked from this chapter. There is one just convention. Sometimes you are given that x of n is equal to 4 into delta n plus 3 into delta n minus 1 plus 2 into delta n minus 2 plus delta n minus 3. Okay, if you are given such and you are told to find x of n, it is nothing but the coefficients. So 4, 3, 2, 1. And suppose it is of 6-point sequence. If it is 6